Hello, hello, hello. Welcome back. We are in Chapter 6%. This is Lesson 3, using properties with rational numbers. We're going to start off with two story problems, and we're just going to go over them just for some extra practice. The first one says, Gomez details motor vehicles. Last weekend, he detailed 3 cars for $35 each and 3 SUVs for $50 each. How much did Gomez earn for detailing last week? Well, to figure this out, if we take the number of cars multiplied by the price or the cost of detail, we can go ahead and figure out that total cost. However, for this problem, the cost of detail is 2 different values. So we're going to split this up into 2 different things. So for this first part, he detailed 3 cars for $35. So we're going to multiply that by 35. And then to figure out the total cost, we're going to add that to the 3 SUVs he detailed for $50 each. So there's our expression. Now we're just going to do the order of operations, which states we're going to, we have to multiply left to right first. So we're going to multiply 35 times 3. I'm going to do that off to the side. 3 times 5 is 15. Write the 5, carry the 1. 3 times 3 is 9, plus 1 is 10. So this ends up being 105. Plus 3 times 50. 50 times 3. 3 times 0 is 0. 3 times 5 is 15. That's equal to 150. Now I just need to add those 2 costs together. And 5 plus 0 is 5. 0 plus 5 is 5. 1 plus 1 is 2. So he made a total of $255. All right, great. Let's go ahead and work out problem 2. It says Lucy and Sam both ordered themselves the same lunch each day during their 5-day work week. Lucy orders the $5.75 turkey sub combo, and Sam orders the $7.25 pasta salad combo. How much more does Sam spend than Lucy each week? Okay, so the first thing we need to do is figure out how much Lucy spends and then how much Sam spends. So Lucy spends $5.75 each day for 5 days. So that's how you figure out how much Lucy spends. Whereas Sam spends, the cost of his lunch is $7.25 for 5 days. So we multiply that by 5. So we just need to figure out these values. $5.75 times 5. 5 times 5 is 25. Write the 5, carry the 2. 5 times 7 is 35, plus 2 is 37. Write the 7, carry the 3. 5 times 5 is 25, plus 3 is 28. It's decimal, so we have 2 decimal places here, which means we have to have 2 decimal places there, which means we end up with 28.75. So Lucy spends a total of $28.75 each week. Okay, now we have to figure out how much Sam spends. So I'm going to go 7.25 times 5. 5 times 5 is 25. Write the 5, carry the 2. 5 times 2 is 10, plus 2 would be 12. Write the 2, carry the 1. 5 times 7 is 35, plus 1 is 36. There's 2 decimal places here, which means there has to be 2 in my answer, which means Sam spends a total of $36.25. So to figure out how much Sam spends more than Lucy, we just need to subtract $36.25 from $28.75. 5 take away 5 is 0. We need to borrow, making that a 5. This a 1. 12 take away 7 is 5. Whenever you're subtracting decimals, the decimals have to line up. The 5 isn't big enough, so we have to borrow from the 3, making that a 2, making that a 1. 15 take away 8 is 7, and then 2 take away 2 is 0. So Sam spends $7.50 more than Lucy each week. So that is how you would solve that particular story problem. All right, let's move on to problems 3, 4, and 5. We're going to do these ones together, and then you're going to have some that you're going to do on the next page by yourself. So this says write the equivalent equation that does not contain fractions, then solve the equation. So remember, what we have to determine is what the LCM is for 2 and 4, okay? So for 2 and 4, if we count by 2s, 2, 4, hey, we just got a 4. So we know the LCM is 4. So we're going to multiply both sides of the equation by 4. So we're going to multiply this side of the equation by 4 and this side of the equation by 4. So it's going to be 4 times 1/2 x and then 4 times 1. So 4 times 1/2 x plus 4 times 1. And then we're going to do the same thing on the other side of the equation. 3/4 times 4. Now we're going to work out these little problems right here, these little mini problems. I'm going to make this 4 over 1. I'm going to look to cross cancel. With 4 and 2, 2 goes into 2 one time and 2 goes into 4 2 times. I multiply across. 2 times 1 is 2. 1 times 1 is 1, so I'm just going to leave my answer. 2 over 1 is the same thing as 2, so I have 2x plus 4 times 1 is 4 equals, I'm going to make this a fraction, 4 over 1. Whenever I'm multiplying fractions, I look to cross cancel first. The 4 and the 4 have a common factor of 4. 4 goes into 4 one time, 4 goes into 4 one time. I multiply across and I get 3 times 1, which is 3, over 1 times 1, which is 1, and 3 over 1 is just the same thing as 3. Perfect. Now it's time to get x by itself. I have an equation that no longer has fractions, so that's the cool little trick about multiplying by the LCM. You can get rid of the fractions entirely. You can still solve this problem with the fractions, no problem. But this is a way to get rid of the fractions. So at this point, we have a two-step equation. We're going to get x by itself. We know we have to keep this 2x together until the bitter end. So the first thing we need to do is get rid of this positive 4. To do that, we're going to do the inverse operation, which would be subtracting 4 to both sides. This cancels. We drop down the 2x. We end up with 3 take away 4. 3 is positive, 4 is negative. We see that the signs are different. So when the signs are different, you take the difference. So we're going to find the difference between 4 and 3, which is 1. And then we look at 4 and 3 to determine whether this 1 is positive or negative. And 4 is bigger, 4 is negative. That means our answer is going to be negative. Now we still have to get x by itself. X is not by itself. It's 2x, so we have to get rid of the 2. The 2 is related to the x by multiplication. So we have to do the inverse operation, which would be dividing both sides by 2. And we end up with our answer. 2 divided by 2 is 1, right? 1 times x is x. We end up with x equals negative 1/2. And that's our answer right there. Okay, cool. Let's go ahead on to problem 4. So problem 4, we have 3/4 x minus 4 equals 1/2. So again, we have to find the LCM, the least common multiple between 2 and 4. We just found that if you count by 2s, 2, 4, you end up with 4. So we know that the least common multiple is going to be 4. So that means we're going to multiply both sides of this equation by 4. So I'm going to rewrite the equation and then multiply everything by 4, both sides. So it's going to be 4 times 3/4, and then 4 times a negative 4. So 4 times 3/4 x minus 4 times 4 equals 1/2 times 4. Okay, so I'm going to be multiplying these fractions. I'm going to make this 4 a fraction. Whenever I'm multiplying fractions, the first thing I do is look to cross cancel. I look to see if there's a common factor between 4 and 4, and there is. 4 goes into 4 one time, 4 goes into 4 one time. Can't do anything here, so I multiply across. 1 times 3 is 3, and 1 times 1 is 1. 3 over 1 is the same thing as 3. I'm going to leave it as 3. 3x minus 4 times 4 is 16 equals 1/2 times 4. I'm going to make it 4 over 1. Now I'm going to multiply these fractions by first looking to cross cancel. Is there a common factor between 2 and 4? The answer is yes. 2 goes into both. 2 goes into 2 one time. 2 goes into 4 2 times. Then I multiply across. 1 times 2 is 2. 1 times 1 is 1. Boom. 2 over 1 is the same thing as 2. So now I'm trying to figure out what x is. Okay, I know I have to leave this 3x together until the bitter end. Okay, so I have to get rid of this negative 16 first. Now the inverse of negative 16, or subtracting by 16, would be adding by 16 to both sides of the equation. This negative 16 and that positive 16 are going to cancel out, which means we're going to be left with 3x equals 2 plus 16, which is 18. I'm trying to get x by itself. It's not by itself yet. There's a 3 that's multiplied by it. So I have to do the inverse operation of multiplication, which would be dividing 3 to both sides. 3 divided by 3 is 1. 1 times x is x. And 18 divided by 3 is 6. So the final answer for this one would be x equals 6. Okay, we're going to go ahead and do one more problem together before you start working on these on your own. So we have 1/8 x plus 2 equals 3/4. So the fractions are 4 and 8, so we have to find the least common multiple between 4 and 8. Well, if we count by 4s, we have 4, 8, wow, we run into an 8 really quick. So therefore we know that 8 is going to be the least common multiple, which means we're going to have to multiply both sides of this equation by 8. So I'm going to rewrite it. 1/8 x plus 2 equals 3/4. And we're going to multiply this side of the equation by 8 and also this side of the equation by 8. So let's go ahead and do that first. We're going to go 8 times 1/8 x and also 8 times 2. So 8 times 1/8 x plus 8 times 2 is going to equal 8 times 3/4. So 3/4 times 8. Yeah, so let's just go ahead and start these little mini problems. So we're going to make this 8 into a fraction. 8 over 1 times 1/8 x. And we're looking to cross cancel, and there's a common factor of 8. 8 goes into 8 one time, 8 goes into 8 one time. We multiply across, and we get 1 times 1, which is 1, over 1 times 1, which is 1. And so this just ends up being 1x. Plus 8 times 2 is 16. And then we make this 8 over 1. We look to cross cancel. There's a common factor of 4. 4 goes into 4 one time. 4 goes into 8 two times. We multiply across. We get 3 times 2, which is 6, over 1 times 1, which is 1. So, yeah, we just have this. We are trying to get x by itself. We have 1x, which is really just the same thing as x, right? So x is by itself except for on this positive 16. So we need to get rid of the plus 16 by doing the inverse operation, which would be subtracting 16 to both sides. Those cancel. 1x is the same thing as x equals 6 take away 16. Well, 6 is positive and 16 is negative, so the signs are different. So we got to take the difference between 16 and 6, which is going to be 10. And then we just need to determine if it's a positive 10 or a negative 10 by looking at 6 and 16. 16 is the bigger number, 16 is negative, so that means that this is going to be a negative 10. So there's our answer right there. X equals negative 10. So let's go ahead and flip the page, and now I want you to go ahead and work on these on your own. Write an equivalent equation that does not contain fractions, then solve the equation. So 6, 7, 8, 9, 10, and 11. So here's our friend the pause dragon, reminding you to pause your device, and when you get done with those problems, make sure you press play and we'll go over them. All right, see you in a bit. See you in a bit. All right, we are back with problem 6, and so let's see how you did. When I'm looking at problem 6, I notice there's fractions. There's a 6 and a 12 in the denominator, so we need to find the LCM. That means if I count by 6, I'm going to go 6, 12, and then 12 is actually the same number. So I know that this is going to be our LCM. I'm going to have to multiply both sides of the equation by 12. So first I'm going to rewrite this problem. And then I'm going to multiply this side of the equation by 12 to get rid of the fractions. It's just a really nifty trick to get rid of all the fractions. You can solve it with the fractions in it, but sometimes this can be easier. So now I'm going to use a distributive property and multiply the 12 by 1/6, so 12 times 1/6x. And then I'm going to go 12 times 5, so minus 12 times 5 equals 5/12 times 12. Okay, let's do this bit. This is going to be 12 over 1. I'm multiplying fractions. I'm going to look to cross cancel. The common factor between 12 and 6 is 6. 6 goes into 6 one time. 6 goes into 12 two times. I multiply across. 2 times 1 is 2. 1 times 1 is just 1, so it's just the same. It's the same as 2x. Minus 12 times 5 actually ends up being 60. Equals, make this 12 over 1. We're multiplying fractions, cross cancel. They cancel each other out and become 1. We have 5 times 1, which is just 5, over 1 times 1, which is 1, so it's just 5. We're trying to figure out what x is. This is a two-step equation. We know that we have to leave this 2x until the bitter end. So the first thing we're going to do is get rid of this negative 60 by doing the inverse operation, which would be adding 60 to both sides. This cancels out. We drop the 2x. 5 plus 60 is 65. And then we are going to get x by itself by getting rid of this 2. The 2 is related to the x through multiplication, so we have to do the inverse operation of multiplication, which would be division. We're dividing both sides by 2. 2 divided by 2 is 1. 1 times x is x. We're left with 65 divided by 2. I'm not sure, well, that's the answer, 65 divided by 2. Or you could change it into a mixed number. And that's totally fine that you have an improper fraction. This is reduced, it's simplified. But if you wanted to change it into a mixed number, you have to figure out how many times 2 goes into 65. So I'm going to do the long division here. 2 goes into 6 3 times. 3 times 2 is 6. I subtract. I drop that 5 like it's hot. 2 goes into 5 2 times. 2 times 2 is 4. With a 1 remainder. So I know that 2 goes into 65 32 times with 1 left over. So 65 over 2 is actually the same thing as 32.5. If you got that right, great job. Okay, on to problem 7. We have 3/5 x plus 3 equals 3/10. Now, the numbers in the denominator on the fractions are 5 and 10, so we need to find the LCM of 5 and 10. If I count by 5s, 5, 10, well, then, you know, we get 10 pretty easy. So we know that the LCM is going to be 10. So that means I'm going to multiply both sides of this equation by 10. So I'm going to rewrite it. 3/5 x plus 3 equals 3/10. I'm going to multiply both sides by 10. 10 times 3/5 x and then 10 times 3. So I'm going to get 10 times 3/5 x plus 10 times 3, and that's going to equal 10 times 3/10, so 3/10 times 10. Now I'm going to do these little problems, make this 10 over 1. I'm going to look to cross cancel. The common factor between 5 and 10 is 5. 5 goes into 5 one time. 5 goes into 10 two times. Then I multiply across. 2 times 3 is 6. Over 1 times 1, which is just 1. 6 over 1 is the same thing as 6, so I can write 6x plus 10 times 3 is 30. I'm going to make this 10 over 1. I look to cross cancel. The common factor is 10. 10 goes into 10 one time, 10 goes into 10 one time. I multiply across, I get 3 times 1, which is 3, over 1 times 1, which is 1. 3 over 1 is the same thing as 3. So I'm just going to leave it as 3. I'm trying to determine what x is. Okay, I have a two-step equation, which means I'm going to leave this 6x together until the very end. Which means I need to get rid of this positive 30. I'm going to do that by doing the inverse operation, which would be subtracting both sides by 30. This cancels. I'm left with 6x equals. This is a positive 3 and a negative 30, so the signs are different, which means I need to find the difference between 30 and 3. And if I take 3 away from 30, I get 27. And then what I need to do is figure out if it's a positive 27 or a negative 27. So I look at these two numbers. I notice that 30 is bigger and 30 is negative, so that means my answer is going to be negative. Okay, I'm still trying to find out what x is, so x has to be by itself, but right now it's not. It's currently being multiplied by 6, so I have to do the inverse operation of multiplication, which would be division of 6 to both sides. I end up with x equals negative, and I think this one I can reduce a little bit. I think that 3 goes into both of those. 3 goes into 6 2 times, and 3 goes into 27 9 times, so my answer would be negative 9 over 2, which is an improper fraction, which I could write as a mixed number, and it would be negative 2 goes into 9 4 times, because 2 times 4 is 8, and then there would be 1 left over, and you just keep that same number on the denominator. So that would be the answer right there for that one. So if you got those right and you have the improper fraction as well as the mixed number, great job. Okay, on to problem 8. So I'm going to go ahead and give me some space here for that problem. We have 2/3 x minus 2 equals 5/6. So I'm looking at the numbers that are in the denominator of the fractions. I have 3 and 6, so I need to find the LCM. That means I'm going to have to count by 3s and count by 6s until they have that number in common. So when I count by 3s, 3, 6, oh wow, there's 6 right there. So that means I'm going to be multiplying everything by 6. So first I'm going to rewrite the equation. 2/3 x minus 2 equals 5/6. I'm going to multiply this side of the equation by 6 and multiply this side of the equation by 6. It's equations, so you have to do things equally to keep things in balance. Now I'm multiplying, so I'm going to use a distributive property. I have to distribute this 6 to both things. 6 times 2/3 x and also 6 times negative 2. So I'm going to rewrite that. 6 times 2/3 x and minus 6 times 2 equals, I'm going to multiply 5/6 times 6. So 5/6 times 6. Now I just do these individual little problems. Once I have written it out, this becomes 6/1. Multiplying fractions again, I look to cross cancel. The common factor between 6 and 3 is 3. 3 goes into 3 one time, 3 goes into 6 2 times, and then I multiply across. 2 times 2 is 4. Over 1 times 1 is just 1, so 4 over 1 is the same thing as 4. I drop down the x. Minus 6 times 2 is 12. Equals 5/6 times 6. I'm making this a 6/1. Multiplying fractions, so I look to cross cancel. These 6's cancel each other out, and everything becomes 1. I multiply across. 5 times 1 is 5. 1 times 1 is 1. 5/1 is the same thing as 5. Now I have my two-step equation that doesn't have fractions anymore. I got rid of the fractions. So now I'm trying to figure out what x is. I know that this is a two-step equation, so I'm going to leave this 4x together until the very, very end. So I have to get rid of this negative 12 first. I'm going to do that by adding 12 to both sides. The negative 12 and the positive 12 are going to cancel each other out. I'm left with 4x equals 5 plus 12, which is 17. And now it is time to get this x by itself. Right now it is being multiplied by the 4, so I have to do the inverse operation of multiplication, which would be dividing by 4 to both sides. 4 divided by 4 is 1. 1 times x is x. I'm left with 17/4, and I don't think I can simplify that at all. So that is my answer, 17/4 as an improper fraction. But if I wanted to write this as a mixed number, I would need to figure out how many times 4 goes into 17, and it goes in 4 times, because 4 times 4 is 16, and then there's 1 left over. So 4 and 1/4 is the same thing as 17/4, and so that is what x equals. So if you got that right, great job. Okay, let's move on to problem 9. Okay, we have problem 9, which is 4/5 minus 1 equals 2/3. So the first thing we're going to have to do is determine what the LCM is. So that means we have to count by 3s, we have to count by 5s. So when I count by 3s, I get 3, 6, 9, 12, 15, 18. When I count by 5s, I get 5, 10, 15, and then there we go. I see that 15 is the least common multiple between 3 and 5. That means I have to multiply this whole equation by 15. So I'm going to rewrite the equation first. 4/5 x minus 1 equals 2/3. I'm going to multiply this side of the equation by 15 and also multiply this side of the equation by 15. Whenever you're doing things to equations, you have to do the same thing to both sides. Now it's time to use the distributive property. I'm going to go 15 times 4/5 x and also 15 times this -1. So I'm going to write minus 15 times 1. That equals 2/3 times 15. So 2/3 times 15. Perfect. Now I'm going to simplify this. So I'm going to make this little part here 15/1. I'm going to be multiplying fractions, which means I always have to look to cross cancel first. I can't do anything with the 1 and the 4, but the 15 and 5 have a common factor of 5. 5 goes into 5 1 time, 5 goes into 15 3 times. When I multiply across, I get 3 times 4, which is 12, and then 1 times 1, which is 1. So just it's the answer, 12/1 is the same thing as 12. So it's going to be 12x minus 15 times 1, which is 15, equals, I'm going to make this 15/1. I'm going to look to multiplying fractions, so I look to cross cancel. Nothing I can do there with the 1 and 2, but the 3 and 15 both have a common factor of 3. 3 goes into 3 1 time, 3 goes into 15 5 times. I then multiply across, and I get 2 times 5, which is 10, and then 1 times 1, which would be over 1, and 10/1 is the same thing as 10. So now I have my two-step equation. I have an equation that no longer has any fractions in it. So I'm going to get x by itself. To do that, which means I'm going to keep this 12x together until the very, very end. And this means I need to get rid of this -15. To do that, I'm going to do the inverse operation of subtraction, which would be addition of 15 to both sides. I'm left with 12x equals 10 plus 15 is 25. I need to get x by itself, and right now it's being multiplied by 12, so I have to do the inverse operation of multiplication, which would be division by 12 to both sides. 12 divided by 12 is 1. 1 times x is x equals, can I reduce this? The only thing that goes into 25 is 5, and 5 doesn't go into 12. So this is in simplified form, 25/12, and that's okay. That's an improper fraction. But if I wanted to write it as a mixed number, I would see how many times 12 goes into 25. And 12 goes into 25 2 times, because 2 times 12 is 24, which means there'd be 1 left over. So that would be the answer right there with the improper fraction and the mixed number. All right, so if you got that one right, perfect, great job. Let's go ahead and move on to problem 10. So we have 8 and 5, okay? So we are going to have to find the LCM between 8 and 5, the numbers in the denominator. If we count by 5s or count by 8s, we got to figure out what that least common multiple is. So let's go ahead. I'm going to start here counting by 5s. If I go 5, 10, 15, 20, 25, 30, 35, 40, and then I count by 8s, and I go 8, 16, 24, 32, 40. I see that the least common multiple is going to be 40. So that means that I'm going to have to multiply this entire equation by 40. Okay, so I'm going to rewrite it. 1/8x minus 5 equals 2/5. And then I'm going to multiply this side of the equation by 40, and also multiply this side of the equation by 40. So to do that, I have to use a distributive property. I'm going to go 40 times 1/8 x and also 40 times the negative 5. So 40 times 1/8 x minus 40 times 5 equals 2/5 times, you're going to go 40 times that, times 40. Okay, each one of these 40s I'm going to make a fraction, so it's going to be 40 over 1. And I'm multiplying fractions, so I'm going to look to cross cancel. I'm going to see if there's a common factor between 8 and 40, and there is. The common factor is 8. 8 goes into 8 one time, 8 goes into 45 times. Then I multiply across. 5 times 1 is 5. 1 times 1 is 1, so 5 over 1 is the same thing as 5. So it's going to be, we're going to drop down that x, and the answer is 5x minus 40 times 5. Since there's a 0, I'm going to go 5 times 4, which is 20, and then just add that 0, so it's 200, equals, I'll make this 40 over 1. I'm multiplying fractions, so I'm going to look to cross cancel. Can't do anything with a 2 and 1, but the 5 and 40 have a common factor of 5. 5 goes into 5 one time, 5 goes into 40 8 times. Then I look to cross cancel. 2 times 8 is 16 over 1 times 1, which is 1. 16 over 1 is the same thing as 16, so I'm just going to leave my answer like this. Okay, so I'm going to try to figure out what x is. Okay, right now this is a two-step equation, so I need to leave this 5x together until the very, very end. So with that said, that means I need to get rid of this negative 200 or minus 200, which the inverse operation of subtraction would be addition. Addition of 200 to both sides. The negative 200 and the positive 200 cancel each other out, which means I'm left with 5x on this side of the equation. 16 plus 200 is just 216. I'm trying to get x by itself. To do that, I have to get rid of the 5. Right now, the 5 is being multiplied by the x, so I have to do the inverse operation of multiplication, which would be division. I'm going to divide both sides by 5. 5 divided by 5 is 1. 1 times x is x. Equals 216 divided by 5. Well, the only thing that goes into 5, I want to see if this is in simplified form, is 5. And 5 does not go into 216 because it does not end in a 0 or a 5. So I know that this is my answer, 216 over 5. That is in simplified form. Now, if I wanted to determine, if I wanted to put this into a mixed number, which I do, I need to figure out how many times 5 goes into 216. So to do that, I'm going to have to do some long division. So I'm going to do that right here. 216 divided by 5. 5 doesn't go into 2, but 5 does go into 21. It goes in 4 times. 4 times 5 is 20. I subtract. 1 minus 0 is 1. 2 minus 2 is 0. I drop that 16 down like it's hot. 5 goes into 15 3 times. 3 times 5 is 15. And there's 1 left over. So I know that 5 goes into 216 43 times, and there's 1 left over, 1 out of 5. So there we go. There is my answer right there. X equals 216 divided by 5, or 43 1/5. So now it is time to do problem 11. So problem 11, the numbers that are in the denominators of the fraction are 9 and 18. So to get rid of the fractions, we have to multiply that entire equation by the LCM, which would be the LCM out of 9 and 18. So to figure that out, I'm going to count by 9s. 9, 18, well, boom. That's the same thing as 18, so we know that the LCM is going to be 18, so that's what we're going to multiply everything by. So I'm going to rewrite this equation. 118x plus 1 equals 7/9. I'm going to multiply this side of the equation by 18, and then multiply this side of the equation by 18. So I'm just going to use a distributive property, 18 times 1/18 x, and then 18 times 1. So I have 18 times 1/18 x plus 18 times 1. And that equals 7/9 times 18. Okay, I'm going to just simplify this. So make this 18 over 1. I'm multiplying fractions, so the 18s cancel each other out and become 1. I just have 1 times 1, 1 times 1. That's all equal to 1. 1 times x is just x. Plus 18 times 1 is 18. Equals 7/9 times 18. I'm going to make this 18 over 1. I'm going to look to cross cancel. 9 and 18 have a common factor of 9. 9 goes into 9 one time, 9 goes into 18 two times, and then I multiply across. 7 times 2 is 14. 1 times 1 is 1, so it's just 14 over 1 is the same thing as 14. I'm trying to get x by itself. The only thing around x on this side of the equation is the positive 18, so I need to do the inverse operation of adding 18, of addition, which would be subtraction. I'm going to subtract both sides by 18. Positive 18 and a negative 18 cancel out and become 0. I'm left with x equals, I have a positive 14 and a negative 18. So this is positive, this is negative. The signs are different, so I need to find the difference between 18 and 14. The difference between those two, 8 take away 4 is 4. So the difference between 18 and 14 is 4. I need to determine if it's a positive 4 or a negative 4. So I'm looking at 18, I'm looking at 14. 18's bigger, 18's negative. So my answer is going to be negative 4. So x equals negative 4. So if you got that one right, great job. Perfect. Okay, let's go ahead and work on problem 12. This is the last one. The problem states that Paige spent $7.55 on some report covers and 1 lanyard at the spirit shop. Each report cover costs 35 cents and the lanyard costs $6.50. How many report covers did Paige buy? Write and solve an equation without decimals. Okay, so let's go ahead and figure out the important information. So Paige spent $7.55 on some report covers and 1 lanyard at the spirit shop. So the total cost that made up of report covers, I don't know why I can't say that, report covers and 1 lanyard, okay? And then what it tells us is it tells us the price of each. It says each report cover costs 35 cents and a lanyard costs $6.50. Okay? How many report covers did Paige buy? All right, so what's the thing we don't know? It's usually in the sentence. How many report covers did Paige buy? So we don't know how many report covers, so that's going to be our variable. So we're going to say let x equal the number of report covers bought. Okay? So this example of a problem, we're going to write an equation. What we have is we have a total cost, and then the total cost is made up of pieces. So the total cost for this one, it has 2 pieces. It's made up of report covers, so cost of report covers plus the cost of the lanyard. All right, so we're just going to fill it in. The total cost is $7.55. That equals the total cost of the report covers. Now, the report covers, we know how much individual report cover costs, but we don't know the number of report covers we bought. So to figure that out, what we do is we put the cost, 35 cents times the number of report covers, which would just be X, which we don't know. So 0.35X is going to give us the total cost spent only on the report covers. And then we're going to add that to the cost of the lanyard, and they just bought 1, and the cost of the lanyard was $6.50. Perfect. So this is our equation right here. Okay, now this is a 2-step equation. We could use our math skills that we've worked on before and totally figure this out. But what this problem is asking us to do is write and solve an equation without decimals. So we got to get rid of the decimals. So to get rid of the decimals, what we have to do is we have to count up what's the biggest number of decimal places. So this is the tenths, this is the hundredths. So far hundredths is the biggest. Let's check here. Tenths, hundredths. Hundredths is still the biggest. Tenths, hundredths. Hundredths is still the biggest. So what that means is that we have to multiply both sides of this equation by 100 in order to get rid of the decimals. It's just a little trick. So we're going to multiply this by 100 and this side by 100. So we're going to go 100 times 7.55 equals, and then we're going to do distributive property here, 100 times 650 and 100 times 0.35x. So 100 times 0.35x plus 100 times 650 like that. Now the cool thing is whenever you multiply a number by 100, you can just move it over, the decimal place over 2 places, and you get the same answer. So 100 times 7.55, we move this decimal over 2 places, and we get 755. 100 times 7.55 is the same thing as 755. Equals 100 times 0.35x, we just move it over 2 places, and we get 35x. Plus 100 times 6.50, we just move it over 2 places, and we get 650. Okay, so this is our equation with no decimals. We just multiplied everything by 100 and boom, no more decimals, they are gone. Okay, so this is a 2-step equation. We're trying to figure out what x is. Okay, we're gonna leave this 35x together until the very, very end. Okay, so which means we have to get rid of this adding 650. So we're adding 650, we have to do the inverse operation of adding 650, which would be, of addition, which would be subtraction. So we're gonna subtract both sides by 650. When we do that, we get 5 take away 0, which is 5, 5 take away 5, which is 0, 7 take away 6, which is 1, equals 35x. We need to get x by itself. Right now it's being multiplied by 35. So we need to divide both sides by 35. The inverse operation of multiplication is division. 35 divided by 35 is 1. 1 times x is x. So now x is by itself. And we have 105 divided by 35. I'm pretty sure that 35 times 3 is 105. I'm going to do that on the side. 35 times 3. 3 times 5 is 15. Write the 5, carry the 1. 3 times 3 is 9, plus 1 is 10. So yeah, it's 105. That means 105 divided by 35 is 3. So x equals 3. So when it asks how many report covers did Paige buy, we can say Paige bought 3 report covers. And that's our answer right there. So, all right, we will see you next time. Goodbye.